Alright, today we're going to prove what is called the angle sum theorem for triangles. So basically, the theorem says the sum of the measures of the interior angles of a triangle is 180 degrees. So in this diagram, we have a triangle ABC with interior angles here marked as alpha, beta, gamma. Now, the theorem says that the summation of the measure of the triangles interior angles are 180 degrees. So how are we going to prove that? So of course, in geometry, we base a lot of theorems or results from the fundamental assumptions. There's a famous like a 5 axioms of geometry, and one of it is regarding the right angles, and also in this particular result from that is that if a straight line stands on another straight line, then it makes either two right angles or angles whose sum equals to two right angles. So in this case, I have AB and line on the line CD. In this case, we're saying that this angle ABC, right, and the other one with ABD is going to sum up to two right angles, which is 180 degrees. Or in another case, if BE here is perpendicular to CD, then we're going to have two right angles. In this case is EBC and EBD. All right, so that's we consider this fundamental result as given for now, for the moment. Now from that result, when we look at this diagram here, so we have two straight lines, red one and black one. So if you take the black line as a reference point and apply the result we just discussed, then you know that if this angle is alpha, this angle is alpha, and then the other one must be 180 degree minus alpha. All right. Now similarly, if you take the red line as a baseline, and if you take the black line as intersection line, then what you have is, if this is alpha, again the same angle is alpha, then the other one must be 180 degree minus alpha. Combine the two results together. In other words, if we use the results from the black line as a baseline, you're going to have 180 degree minus alpha. So what you can see here in this diagram is that there's some relationship here. If you have two straight lines, right? So we're going to have four angles, and the result we have displayed here is that the vertical angles equal to each other. Both, in this case, the vertical angle, they're all equal to 180 degree minus alpha. All right. Now, similarly, of course, you can derive the result that the other one, the vertical of this alpha angle is also alpha. All right. So that is the vertical angles are congruent. This is the theorem. And of course, when we talk about the measure, in other words, the magnitude of angles, sometimes if two are equal to each other, we say these two angles are congruent. Now you have four angles here. When we look at the two straight lines intersecting at a single point. Now in this case, in this diagram, the A and B are a pair of vertical angles, and so are C and D. So in this case, A equal to B and C equal to D. The vertical angles are congruent. That's the result we want to remember and use for the proof of the angle sum theorem later. Now, another very important assumption is what is called the parallel postulate. So that is actually what is called the fifth axioms of geometry, originated from Euclid's classic book called Elements. All right. So here, what it says is, if we have two lines and also another straight line here forming an angle alpha and beta, right? So if the sum of the interior angles alpha and beta is less than 180 degrees, then these two straight lines is going to meet, at this side, somewhere, here. Now, in other words, if the lines are parallel, then the summation here must be 180 degrees. So, but again, we don't prove this. We take this as a fact, as an assumption here. And based on this, result, this is based on this assumption, we can have this conclusion that if we have two lines that are parallel, right, and also the red line is kind of what is called the transversal of these two parallel lines, and the corresponding angles here, alpha and alpha 1, are congruent, and this again, this is a direct result of the previous parallel prospect. Now, of course, we can also have the result that the alternate interior angles equal to each other. All right. So again, this can based on the combination of the results we just discussed. One is that the corresponding angles here, which is not marked, but then this angle, the vertical, is 1. They are congruent, and then this one and number 2 are congruent, so 1 and 2 are congruent. All right. So this result is called alternate interior angles. All right. Now let's use the previous result and try to prove, the angle sum theorem here. So in other words, in this diagram we try to prove that alpha plus beta plus gamma equal to 180 degrees. Now, in geometry, a lot of times we use what is some tricks by, for example, extending or adding some constructions to show the proof. Now, in this case, we are extending the 9th segment BC of this triangle to BCD. This is a straight line here. Okay, BD is a straight line. And in the meantime, we draw a parallel line from point C. We get CE parallel to AB. But you may wonder, is this always possible? Is it possible to always draw a parallel line? And is this line unique? And the answer is yes for both. And of course, for the purpose of this video, we are not going to prove that. All right. So we assume we can do that, and this line is actually unique. Now in this case, we're going to apply the result we just learned about the fact that if we have two parallel lines, in this case AB and CE, and then the third line, which is BD here, is the transversal of two parallel lines, and we're going to apply the results. So for example, the first result I'm going to use is the fact that in this case the corresponding angles equal to each other. So beta here and the mu, they are equal. All right. And we also learned that if we have two parallel lines, in this case AB and CE, and if we treat AC as the transversal, and we're going to have a alternate interior angles are equal to each other. In this case, alpha, and the alternate one is this. I think this we're going to say nu here, and alpha equal to nu. All right. So, but then if you think in this case alpha, beta, gamma, since alpha equal to nu and beta equal to mu, and gamma of course is unchanged. But these three angles here is actually from the straight line, right? So the BCD, the straight line here, so we know that that would be 180 degrees. Of course, this is from the very first results, right? If it's a straight line and then the angles, sum up to 180. So by combining the results, earlier, so we have these steps, 1, 2, 3 equations, and then at the end you're going to see that the summation of interior angles equal to 180 degrees. And this concludes the proof, and hope to make some new videos in the future in the area of elementary mathematics or geometry. And again, this is for Angela's learning. All right, thank you for your time. Bye-bye.